Okay, guys, so now that we have our subsetted image, we're going to look at some different band combinations that are useful in identifying land cover. Okay, so the first one we can do is quite simple. We just go open RGB image window. We go to the profile and we select option number 2, Sentinel-2 MSI false color infrared. Once that's selected, that will automatically change the bands to band 8, band 4, and band 3. This is a combination of standard near infrared, red, and green bands. It's used to identify plant density and health, and the colors that you get from this image is that once plants appear deep red, cities can appear grey or tan, and bare soil can also appear grey or tan. Water will appear blue or black in this image. So if we click OK, we can go ahead and have a look at it. Now to move around the image, we click on the pan feature, and we can have a look around. So straight away we can see a few things. So if we zoom into this image over here, making sure that we can look, this is probably like an industrial area or something like that, and again appears grey or tan. We can then go over to this area here, and we can see forestry, which is in dark red, and we can see bare soil indicating deforestation just adjacent to that. If we look at our agricultural areas, we can see a lighter red, um, and that's consistent, as I said, with agricultural areas in this band. However, you can, if you look a little bit more closely over at our mountain range here, which is in the Wicklow Mountains, um, you can see that it's appearing brown or tan. And this is due to a high water content within the soil, given that it's a wetland or predominantly wetland area, and this can lead to issues in terms of classifying this land type. Now, as a result of this, we can also look at other image band combinations. However, first what we need to do is to resample this image, because the bands, which if we just click here and we look down at our bands, some of these are in different resolutions. So some of them are 20 meter resolution and some of them are 10 meter resolution. So we need to resample them all to be the same resolution, which is 10 meters. To do that, we click on our raster here in your menus, go down to geometric operations, go across to resampling, okay, and this new box appears. Now from this new box you can see that we have already selected the correct image, or in fact I'm incorrect. The image needs to be reselected because we never imported our resampled image. Excuse me, that is the resampled image, so that's great. Okay, so let's go back again. Raster, geometric operations, resampling. A correct image is selected there. We don't need to do anything with the file name, as Snap will add on to the end of this resampled, okay, and that'll indicate to us the new file. So from here we go to resampling parameters. Now we want to resample this based off the resolution of band 2. So what Snap will do, well, it will look at all of the bands, and any band that is not the same resolution as band 2, it will amend that band to be at that resolution. Band 2 is at 10 meters, while many of the other bands are at 20 meters. Now again, we can leave all of these on default, and we just click run. It'll give this message: target product successfully has been created. Just select OK and click close here. So let's just minimize this, so we can see we have a new file here located in our Product Explorer. Now what we can do is we can just zoom out a little bit so we can see this whole image. We right click on in Product Explorer on this image 3, okay, open RGB image window, and we can then see we have many more new options. So let's just go up to the image above. Okay, let's go to the image above and open RGB, and we can see we only have these 3 options, and that's because any of the bands that are required to do the other calculations are at the wrong resolution. This is why we resampled. So this resampled data, again, open RGB image window, and we can select some of the defaults here. So if we're looking to try and find urban areas, we can select this and click OK. And we can see urban areas up here at the top. Okay, so we can go to the pan feature. Okay, and we can zoom in. Let's just take a second here so you can see them up there. Okay, again, we can you can see very clearly the difference in this image between forestry and grassland, I suppose, and or pasture land. And it's showing some interesting things here in some of the land types around the mountain range. So they're interesting characteristics. We can again go back and change this to different color types. So let's have a look at, for example, healthy vegetation. Okay, and again you can see very clearly forestry is even more differentiated here. You can see this is in the red band. You can see bare soil is in a blue band, and this is very beneficial because this bare soil was being in the infrared image, the near infrared. This was classifying bare soil similar to the wetlands, so this is differentiating that. Again, we can see perhaps urban areas being classified in a different in a different color. So this is a good image to look at. You can see your roads quite clearly here. So this is a good image for image classification, which is what we'll be doing later on. So that's it. This is really what's involved in playing around with the different bands. If you're interested in learning more about this, I'll put a link below in the YouTube video description, and you can look at the different combinations that are available and what they tell you. The next video will further develop on this concept, and we'll be looking at using another band combination called NDVI, Normalized Difference Vegetation Index, to further assess vegetation health. Thank you.